Okay, in this video I want to talk about what happens when we take some region and we revolve it about a line that's other than the x-axis or y-axis. So in this case I'm going to revolve this region about x equals 2, and I'm going to get a region that's going to, my integral is going to be a little bit more difficult because of that. So and the same is going to apply as if we do about y equals some number. So I'm just going to do one video and talk about what happens if we revolve this about something other than the x-axis or y-axis. So the first thing I'm going to do is I'm going to draw in our axis of revolution here, which is x equals 2, and I'm going to duplicate this image where it would be symmetric about, which would be between 3 and 4, which looks something like that. And I would get that same exact region over here. And we have revolved that all the way around, so we have some kind of three-dimensional shape going on. And I'll try to make that look that way the best that I can. So it's kind of hard to imagine this. I'm going to try to make that a little bit skinnier. Okay, let's go with that. Okay, so that's what my region looks like. It would kind of be, if you think about it, it would look almost just like the top half of a bagel. I've got a rounded top, flat on the bottom, rotated around, so I would have essentially like the top half of a bagel. And I'm going to use shells. Okay, so if we use shells here, I've got, one of these rectangles, wherever I want to imagine that rectangle to be, each one of these rectangles, and I revolve that around and I get the same rectangle over here, and I have a shell. Okay, so that shell would look like that. Okay, so again, I'm always thinking 2 pi radius height, okay, of each one of these shells. So I'm going to have 2 pi, make that look a lot better, 2 pi times the integral from what to what? Well, where are your rectangles originally? That's what you always want to think. Originally my rectangles are from 0 to 1, and then I rotate them around. So I'm still going to go from 0 to 1. Now, what would be the radius of the shell? Well, the radius of the shell, now I go from 2 to wherever my rectangle, whatever x value my rectangle starts at, right? So how do I say that? Well, again, I have a distance of 2, which goes from 0 out to 2, and I subtract away from that the distance of whatever x value I have my rectangle at, which would give me a radius of 2 minus x. 2 minus x. Now, similarly, if this line were a horizontal line, like let's say I were rotating this about y equals 1, then my radius would be starting from 1 and subtract away the function, or the y value at which I was making my rectangle if they were going horizontally. So just keep that in mind. It's very similar if you do it the other way. Okay, so my radius is 2 minus whatever the x value is for my rectangle, and that will give me, again, that radius. The height of my rectangle each time is simply just the height of the function in this case, right? Just the height of the function. That's always going to be the height of my rectangle for my shell. And so my function was x minus x squared, so that is my height, x minus x squared. And I'm going to have this times dx, and we're ready to integrate. Okay, I need to first FOIL this out, simplify it as much as I can, and then integrate. So 2 pi times the integral from 0 to 1 of, I would have, let's see, 2x minus 2x squared minus x squared and plus x to the third. And so that will give us 2 pi times the integral from 0 to 1 of x to the third minus 3x squared plus 2x dx. Okay, so FOIL that out so that you have individual terms inside here, and then you can integrate and plug it in and evaluate. So 2 pi times 1/4 x to the 4th minus x cubed plus x squared, evaluated from 0 to 1. Again, if you plug in 0, all that's going to be 0. So if I plug in 1, I get a 4th minus 1 plus 1. Plugging in 0 gives me 0. The minus 1 and the plus 1 will cancel each other out, and I get 2 pi times a 4th, which is pi over 2. So that would be my volume of that region. So really the one big thing that changes whenever I revolve around something other than the x or y axis is usually going to be whatever my radius is. Okay? Usually the height is still going to be okay. My radius is probably going to change. And it's just going to change with whatever that axis of rotation is, minus whatever value, whatever variable I'm looking at. So if it's oriented this way, that would be my x coordinate. If it were oriented the other way, that would be my y coordinate. So if you can just picture one shell every time and think about what your radius and what your height would be, the rest from that should follow pretty easily.